All right, this is 42 trapping rainwater. And pretty much with this question, you're just given a height. So in a list of heights, right? In this case, the height 0, then the height is 1, then the height is 0, then the height is 2, right? But then you keep going. And you want to find the trapped rainwater. So in this case, there's rainwater here, there's rainwater here, and here. And how we're going to do this is we want to have a left and a right pointer. And we're going to set the left to 0 and then the right to the length of, let's see, the length of height, and then we're going to subtract 1, right? And we also want to have a left max and a right max. And we're going to set this to the height at the left pointer and then the height at the right pointer. Now we also want to have something to store the rainwater. So let's set this to result, right? Result is equal to 0 for now. And pretty much what we want to do, I'll show you through the code, is we're going to loop through while the left pointer does not go past the right pointer, right? So there's no index out of bounds. And now we want to do if the left max is less than the right max. And pretty much what this is the left max, right? So the left max is set to height at left, and the left pointer is here, so 0. And then the height at right, which is over here, is set to 1. So 0 is less than 1, and pretty much we're going to run this first. And what we're going to do here is we're going to increment the left pointer by 1. So now the left pointer is at this one, the height, the left here, and then the left max is at 0. So then now what we want to do is we want to set the left max, so the maximum height of the left pointer is equal to the max between the left max and then height at the left pointer, the new left pointer. So essentially it's at 0, right? We're comparing left max, which is at 0, and then height at the left pointer, which is over here, and now it's 1. So then what we're going to do is we're going to results plus equals, we're going to add this to the result. So we want to check if there's rainwater. We're going to add the rainwater, and then we're going to do the left max minus the height at, in this case, the left pointer, right? And so what this would look like is the left max, right? So the new max is this one. So it's 1. And then minus the height at the left pointer. The left pointer is also here. So 1 minus 1 is equal to 0. And this is correct because there is no rainwater here, right? We're not collecting anything yet. And so now we're going to do the same thing for the right pointer, right? So if left max is greater than right pointer, then we're going to work with the right pointer. And pretty much same thing, just in reverse. So the right minus 1, and then r max is equal to max r max. So the right max at the height where the right pointer is at. And then we're going to update the rainwater collection. So then this is r max minus height at r. And that's pretty much the code. That's everything you need for this problem. We're just going to return, res. Perfect, we submit. And here it looks, yeah, there you go. This is pretty much how the code works. In the second case scenario, right, we keep running. Now the left max is not equal to, so in this case it would be 1, right? We updated it to 1, and then the right max is also 1, but it's not less than. So then we run this. So right minus 1, it'd be over here, and then the max height is now 2, right? And then we add 2 minus, and since we updated the position of the right pointer, so then now it's 2 minus 2 is equal to 0, and we haven't added any rainwater. So then now we run this one again, since the left max 1 is less than 2. And then we go to here, right? We update the pointer. So now we're at the rainwater. The left max is still 1 because 1 is greater than 0 now. And so now we're adding left max. So 1 minus 0 is 1. So now we got the rainwater. We got 1 rainwater added to the variable. Now, 1 is still less than max. So we keep running this and we keep going through this whole loop until we capture all the rainwater. And that's pretty much how this algorithm works. And so this is 42 trapping rainwater.